Hey folks, my name is not Platima, and this is the Milk-V Duo. So today I'm here to guide you through what it is, how to use it, and how it probably doesn't work. Everyone's been going mental about these things recently, in the last week or two, Reddit, Google, everywhere in between, and so I thought I'd get myself one and find out why, or what's going on. And you know what, I've already killed one, this is my second one, I've got 10 more on the way. These are awesome. Now there's always going to be some apprehension, because it's a C906 in there. There is still some parts of it that don't work. I have to say that up front. This has 2 cores. One of them you can't use yet. Probably Chinese political relationships, but who knows. For now though, we're going to pop this open, going to have a close look at it, see what its specs are, compare it to an OX64, which a lot of people have been doing, and then I'll show you how bloody easy it is to use it. Hold tight. That's better. So first, let's open this up with a Stanley knife that's a bit sharper. Wouldn't it be funny if I just cut straight through it? This thing is bloody tiny. This is what I'm gonna start calling, as someone on Reddit rightly suggested, an eSBC. It's not quite an MCU on its own, but an SBC, like, geez, if I can pull this one up from over here, is normally bigger, like a Raspberry, what's this? So Radix Rock 3A. But like a Raspberry Pi is what you'd consider an SBC. This I'm going to call an eSBC, an embedded SBC, and there's a lot of them going around. I've got over here the OX64, the Mango Pi. This now, I've just had some SciSpeed stuff turn up, but these are too small to be called an SBC on their own, I think. They are pretty bloody awesome though. So you can see straight away that we've got an SPI pins there, we've got an SD card slot, we've got the chip in the middle there, we've got a camera connector, we've got a happy little smiley face just there. I wonder what you can mount there. It looks like maybe an NTC or something. We've got a USB-C connector, bucket load of gold-plated capitalized holes for pins or surface mounting. There is nothing underneath, so you can actually mount this on the surface of another PCB, which is bloody awesome. And all in all, quite a good little design, I reckon. It's 1mm PCB as well, not 1.6. Now, if we grab an OX64 out, I've got one here. Let's just grab one of the smaller ones. I don't think I've even used this one yet, and compare them. So they are identical form factor, identical thickness. The OX64 has USB-C at one end and USB Type A at the other. It's got a boot pin on board. They can have SPI flash already on because that's just how they work. And this has the BL808, which is still riddled with some problems, but they've come a long way. There is also pins that go through to the bottom, unfortunately, where that JTAG header is, and sometimes they don't ship with that, but that doesn't mean it's going to be hard to... Maybe I solder those. That would make it hard to mount. This does not have those features. It's practically identical. It's nearly the same price, being $8 US. They're not available for general purchase yet. I had to go and find the cheapest on AliExpress. As I said, I did buy 10 more though, and I'm going to put them for sale on my website below. I also have some OX64s for sale. I'm going to chuck up some of these MakerFab CP2104s, which will do 2 million bits per second, which the OX64s need, and some other things like that. So have a look in the description below if you want some, especially if you're in Australia, because I'll just chuck it in an Oz Post bag, you'll get it straight away. Now, this is the Svitech 18008, I think. Check information below, or even have a look at that logo there, you can see it. It's a C906 RISC-V ISA. Dual 1 GHz core with 64 meg of RAM. So only come out a few weeks ago, and it looks pretty awesome. The other cool thing, sorry, I forgot to mention, these pads down here, those 5 pins, that's Ethernet. It's got 10100 Ethernet PHY built into it, which is bloody awesome. So the first core is what you're flashing and using. That's the primary one. It does have a second core running at 700 megahertz, so 1 gig and 700 megahertz, which is meant for an RTOS, so you can use it as a watchdog or something like that, but that SDK is not available yet, and I'll put a link to how and why below. Other than that, it is your stock standard eSBC. I consider these extremely powerful, especially for such cheap small devices, and they can run a whole operating system. The way they've done it is that it is powered off the USB-C port. However, if you plug it into a computer with that, it also comes up as a network device that has a static IP of .42.1, that's 192.168.42.1, that you can SSH straight to. From there, you can enable dhclient on this one, or you can set a static IP, start using the GPIOs, stuff like that. It's important to note though as well that with this, these GPIOs are a little bit different. So some of the pins worth noting, besides the JTAG pins, which is 16 and 17 down here. So I believe you've got 16, 17 ground, and I'll show you that when I've connected to it. The documentation is slightly wrong. So the documentation, I think, says 13, 14. Let me have a look. No, so it is actually pins 12, 13, and ground, as opposed to pins 16 and 17, like the documentation says. So bang, bang, bang. Those will get you your serial output if you actually want to watch it boot. Further to that, when you do boot it up, and we'll have a look at that in a tick, you'll see that it says it's got 32 meg of RAM. That's because some is reserved for part of its processing. I forget exactly what it is, but you can change that pretty easily as well. I'll put information on that below. Because it's powered from USB-C though, the main voltage is 5 volts. So the V bus pin, which I believe is that first one, is powered by the 5 volt feed from the USB-C. That's a straight connection as best I can figure out. Then you've got the V sys pin, which can actually take between 5 and 12 volts. So it's got built-in voltage regulation, which is bloody awesome. You then have a 3.3 volt 2 amp pin. I'll put a picture up here for where that is. So I can do 3.3 volts out. It's got the built-in regulator up to 2 amps. So you could actually use this to power a Raspberry Pi. Actually, no, those want 5 volts. But you can use this to power whatever 3.3 volts, 2 amps worth of stuff you want, which is kind of insane. And then lastly, GPIO 24 is tied to the blue LED, so you can control that from the code, which we'll have a look at. And you have a run button, a run pin, which you'll see in the specs as well. Now this, if you look at the schematics, it's actually tied to power VBAT detect, or power VBAT det, which is a battery detection. So what this does, and somewhere in the schematics that I was reading, is this expects 5 volts, and you can pull it to reboot if need be. But the way it works is when the voltage gets low enough, or a little bit lower, it sends a signal to the processor to say, hey, voltage is low. Then when it gets really low, like below, I'm going to assume about 3.7 volts, it cuts it off. So you can theoretically run this straight from a LiPo or from a LiPo source without worrying about draining it. I haven't tested it, but that's part of the chip. I'll include information on that below. And what we could do if we get time is test out serial Wi-Fi. So SDIO 0 is used for one of the connections. SDIO 1 is available for serial Wi-Fi because, same as the OX64, this doesn't actually have Wi-Fi embedded. And this is what makes it slightly different from, say, the ESP32C3, which is also a RISC-V architecture. So first things first, let's jump over to the laptop. I'll show you how easy it is to flash this thing. Beer is good. Kids stay in school. So, first of all, you want to grab an SD card. I've just got a budget Chinese one here that isn't actually 64 gig like it says. You want your eSBC SD card reader if your crappy laptop doesn't have one built in, and your favorite USB-C cable. This is a 2 meter silicon USB-C cable from Pine64. I think I've got 2 or 3 more on the shop below if you want to buy one too. They're brilliant. They'll do 100 watts of power. They'll do 10 gigabit, I think 10 gigabit data. I use them for everything. And they're silicon. So if you're using your Pine64 soldering iron and you rest it on it, as I do all the time, you won't melt it. Bloody handy. I don't have any of these for sale. Sorry, I should get some though. So what you want to do is stick the SD card in your SD card reader the right way up. And then stick that into an SD card, into the USB-C slot in my case. You can then fire up Bellina Etcher, and the image that is currently available is about 20 meg. I'll post a link to it below. All you have to do though is go flash from file, grab the image, select the target, which is going to be that little device, and flash away. When I said 20 meg before, apparently I was full of crap, and it's 403 meg. Maybe it compressed as 20 meg, I forget. But any SD card you can find will probably fit it. If you've got one that's smaller than 512 meg, I want to know if it still works and how old it is, because I haven't seen one of those in a long time. I think I have a 256 meg SD card somewhere at the other place. However, it is a full-size SD card, not these micro SD cards, which, it's no help for something like this. Finishing. I don't even know what it does at this stage. I'm going to skip verification if I ask for that. Now, flashing is complete. Yank it out, pull that out of there, slide that in there like that. Once that's in nice and firm, one end of your USB-C can go into the computer, and one end can go into this. Now, you've got two lights. You've got the power light that's going to come on first. There we go. It's got power. That's what we want to see. If you try to power it from 3.3 volts accidentally, like I've done 100 times testing this and killing one already, then it's not going to work. You're going to get a little flicker and it might have a bit of a sad time. You've then got your data access light up there. That's the blue one that's on GPIO 24. It's probably even, yeah, it's near on the back there so you can see it. That's pretty much your status or your booting, doing something like. Now that that's booted, if we jump back to the computer and have a look in Device Manager, we've got this RNDIS device. Now it's using just some unregistered hardware ID, so the computer's not entirely sure, but all you have to do is go update driver, browse manually, let me pick. It is a network adapter. When your computer, which is old and slow, gets there in the end, you want to go to Microsoft and you want to pick the USB RNDIS adapter. Yes, I'm sure that's the one. I know what I'm talking about. And then you suddenly have this network interface. What that means now is we can fire up PowerShell, if you click the right button, and SSH root at 192.168.42.1. Now, sometimes the first time you connect, it'll take a little bit longer because it's going to have to generate its key. So yes, I trust this one, and the default password is milk-v or milk5. I still say RISC-V instead of RISC-V. It's just more things to say. I'm going to call this milk-v, and we have SSH straight in. So if we have a look at free, so you've got 28 meg of RAM there. That's normal, as I said before. Some of it is in use. 12 meg used is interesting, so that's actually a bit more than what's used by the OX64 by default, but this is running SSH and a pile of other things like that. If you go if config there, we can see there is our USB interface, and it does have ETH0 enabled with what looks like a random hardware MAC address. But it's all going. Disk space, it has not expanded automatically. It is 256 meg by default, and proc CPU info. So we have just the standard RV64 IMA FDV CSU core there. LS var log, what do you got? Not a huge amount. So this is fully functioning at this point. What it doesn't have is internet, for the obvious reason. It's got no connectivity besides our direct connectivity here. So now that that's functioning, there's a few other things that we might want to look at. First of all, we might want to see it boot. If you want to do that, if you're going to do that, you want to solder some header pins onto it or some wire. So let's quickly get that done. Alright, so I might have soldered a few more things than you expected me to, and you might have seen me mess it up and actually solder over the top of one of those SMD components. You've got to be quick because this one does soak up a fair bit of heat. I can feel that in the board, but those are the pins that I want. And so right now we're going to connect these headers for wherever I can find it. One of those CP2104s. Got that there. I've got a USB cable for it. I have it currently set in 3.3 volt mode, so I'm just going to quickly change that with a dicky button up to 5 volt, and we'll connect that with a few wires. So we have from memory ground, TX and RX that should line up perfectly, or TX, RX and then ground with these. There we go, like that. If I got it right, could be wrong, we'll find out soon. And then I'm also just going to grab this pin from there, and that's going straight onto our 5 volt line over here. Now, I'm not going to connect that yet. Let's jump back on the laptop so that you can actually see this booting. So, there we go, everything's in view. If we open up PuTTY, we'll go for COM6 at 115200, connect. Now, it's trying to boot with a tiny bit of current that it's getting through the TX and RX pin. Like, that's literally ground TX and RX. And it's trying, which is hilarious. So now let's actually give it enough current to do something meaningful. And there we go. Look at that. All right, let's go back up. Let's go back up and have it stop scrolling. Have a look at what we've got. So from the very start here, what have we got going on? Boot failed. And then around here is where it starts. DDR init parameters, DDR2, CVert OS build 2023. So it's, I mean, that's from this month, that build. It's doing some stuff that I don't fully understand. Load a second. Jumps to a new address. That's where OpenSBI kicks in. So this does the next bit, which is where we're getting more into the realm that I understand. It's got its config here for this chip and how the output's set up. You can then see a fair bit of the configuration there, which is pretty good, and that sends it straight over to U-boot, which is essentially the main part. So from what I understand, this is all in the chip. This is the bit that you can flash if need be, if you're really going to get hardcore about it. It might even have OpenSBI on there, I'm not too sure. That's a pretty high address there, and I haven't looked closely enough at how it works. But then you got OpenSBI, which can be on there, or it can be on the SD card. I'm going to guess this is on the SD card. Then OpenSBI sets up the hardware, hands it over to U-boot. U-boot knows what it's doing and checks the RAM, does a relocation, and sets up some hardware before going to the SD. Okay, so OpenSBI must be on the chip then. Boot from SD, switching. Loading kernel from image at that address. This is the configuration. Starting kernel, and then boom, straight over to the Linux 5.10.4. So it's a build root version of Linux running 5.10, and you can see it starting to set everything up here. That actually worked really well. Now, the last thing we're going to have a look at is one other option, which is this Ethernet interface. So, well, it's a bit of a dicky connection. Wait for it to boot up again. I'm going to quickly give the Ethernet interface some static details, and then we'll connect an Ethernet module to it, a really bad one, and see if it even works. Hold tight, folks. Alrighty, I just had to quickly solder some wires onto it, but here is said dicky module. I've just gotten a basic RJ45 interface I had lying around. I've done some really bad soldering and melting wires and all sorts of crap on the back that actually works. I checked out, I was just rushing. And then a voltage regulator there. So from here, I'm grabbing the 4 pins, which is your TX and RX plus and minus, plus the voltage pins that are coming out of this. And I'm doing it this way because I'm just powering it by a 24 volt PoE active switch. So you've got to be aware that if you plug it into your laptop, you'll probably cook your laptop. We're using it here because I don't need any special componentry to get the 24 volts off the network line. And it's only 10100, but that's fine because this is only 10100 too. So what we're going to do is connect this up, which will be now I've pre-configured that network interface, and what I've got here is just a really cheap budget, literally $10 PoE switch that is powered off my main PoE switch. I would rather blow up a $10 piece of crap instead of my main switch if I break something. Worst case, I lose 20 bucks, which is, you know, this and that crapo switch. Let's see what happens. All right, we have a power light. That is definitely good. We have a curly cable that wants to do its own thing. Are we going to get a blue light? Are we going to get any activity? Seems not. Have I already killed this one too? This is how I killed the last one. Apparently I'm a slow learner. Now, see, it's having a hard time. That's what killed my last one too. I think what I've done somehow is inadvertently flashed it by doing this. I've got another busted one here. This is what I was playing with before. I'm just going to see if it does the same thing. Yeah, cool. Alright, this is pretty busted too. So what that means is I'm going to have to reach out. Oh, that chip's getting hot. Reach out to the developers, to the hardware team, and see how to flash it over this interface. I'm going to assume that there is a way where I can just pull one of the pins high or low and it's going to go into a boot flashing mode. As it is, it's not particularly happy. It doesn't want to boot the SD card anymore. So this is how to kill the Milk 5 Duo very quickly. It is, however, a bloody awesome little chip. Like, I'm quite happy with these. Let's get that out of the way. I feel like there's something about this that I've forgotten to say. I don't know why. One of the key things as well, when you are actually going to flash it, when you download the firmware, and I'll put a link below, go have a look. I'm going to keep an eye on this. I'm going to try to fix these if I can. And if you want to buy one, I'm going to have some below in stock. I'm hoping it arrives today or tomorrow. Enjoy. Tell me what you make with it. Oh, that's what I forgot to say. It's got a TPU built in as well. I don't know how good it is. It's a pretty tiny chip, but this thing's designed to do some sort of AI. That's why it's got the general purpose core, the Watchdog or RTOS core real-time operating system, and then it's also got the TPU. So it should be really good with this dual lane connector to do live image processing. That's something I'd like to play with one day. It'd probably be awesome running MicroPython on this if you can get it going. If you have any ideas, let me know. If you want to see me try and fail, let me know. But that is how the Milk V Duo do. Till next time, folks, I hope that taught you something interesting. I hope you enjoy playing with these. I hope the OX64 gets better. I feel like the OX64, even though it's only half as powerful as this, could possibly have a lot more capabilities, especially as there are already a lot of them in the wild. We don't know how long these are going to last, if they're going to get into the wild, if we'll get access to that second core. Time will tell. Look forward to all your feedback. Take it easy, stay warm, all those funny things. Catch you next time. Alright, so just one other little note here, that one of them is not dead, but it pretty much overheats instantly. So if I connect it, see it boots up, it looks nearly normal. It actually gets all the way through. And then it hits 140 degrees and turns itself off instantly. And then apparently the other one that I just killed on video is having a really weird issue reading the SD card, the same SD card that just booted. So I think I've killed two different parts of them. It's definitely interesting. I'd love to get an oscilloscope on it and see what's going on at some point, see if there's just like one tiny little thing. Don't connect it like that. I know the Ethernet on these works. I have connected it. I was trying to be smart and use that PoE thing, but I obviously did something really wrong, and it's most likely just because I didn't have diodes on the TX and RX lines, and they're going to be pumping, I don't know, voltage straight into the chip maybe. Don't do it. Don't be dumb. Save your $8 or $17 or whatever the hell it ends up being with shipping.